So the disaster happened on July 25th, 2000. The Concorde took off from Charles de Gaulle Airport and it crashed in Gonesse, Paris. This is a photo of one of the Air France Concordes. It is not the one that crashed, but it is very similar. The Concorde was the first supersonic passenger airplane, and it was created by manufacturers in both Great Britain and France as a joint effort. The first flights were on January 21st, 1976, and they flew from London to Bahrain and from Paris to Rio de Janeiro. The Concordes flew for 27 years before they were retired in 2003, and only 14 of them were ever built. At 4:43 p.m. on the day of the accident, Air France Concorde F-BTSC began to take off from Charles de Gaulle Airport bound for New York City. Earlier that day, a DC-10 jet had used the same runway, and a metal strip from its engine had fallen off. The Concorde ran over this strip and it blew out one of the tires. The rubber shrapnel struck a fuel tank on the left wing, which ruptured it and caused a fire on the underside. The pilot climbed about 200 feet before both left engines failed, and the Concorde then fell from the sky and crashed into a hotel. This is a picture of the Concorde taking off, and as you can see, the underside is fully on fire. The disaster killed all 109 passengers plus 4 of the hotel's workers. The share price of Air France went down drastically, and this caused the stock to be suspended. Air France lost 10% of stock traders and insured families between $600,000 and $1 million.
So, the damage to the environment consisted of atmospheric pollution because of the fire. The windows in nearby places were shattered due to the crash explosion, and other companies started developing supersonic planes. This is a picture of the hotel that the plane crashed into. There were many laws established to prevent the incident in the future. The first law was to suspend the Concorde until the tires are at a more safe level. They then included more mandatory inspections to check the maintenance and operations of the aircraft. New requirements for the tires on aircraft were put into place. They also established a FOD program, or the Foreign Object Debris Program. This also improved workers' awareness of unknown objects on the runway. There were two main sources of material failure in this disaster. The first was the replaced engine part. In a different plane, the strip of metal that was part of a recently replaced engine was made of an alloy of 90% titanium. This strip was supposed to be made of a softer metal in order to increase the safety around airplane tires. This strip, along with the weight of the plane, punctured the tire, which then caused the rupture of the fuel tank number 5. The rupture of this fuel tank is ultimately what resulted in the crash. Now focusing more on the tire of the Concorde, These Goodyear tires were made from a specially reinforced rubber and nylon. They were attached to an alloy wheel rim with high tensile steel wire. Before this event, however, there were 57 cases of tires bursting, 12 instances which damaged the wings or tanks, and 6 cases had the fuel tanks penetrated. Following the disaster, it was seen that the tire was replaced with a Michelin model radial NZG that was more resistant to damage and better at coping with the weight of the plane. The NZG stands for near zero growth. This material had a high modulus and was thoroughly reinforced, which greatly increased its safety and use in this application.
Now moving on to the structure and properties of the tire. The nylon in the Goodyear tires was a linear polymer. This provided elastic properties as well as being very strong. However, when the strain rate is increased, like hitting a foreign object on takeoff, it begins to behave more brittlely. The tire then did not have sufficient hardness to handle the impact, which ultimately resulted in a crash. The exact structure of the new radial NZG tires was not listed, but there was research showing that the tire was lighter, improved foreign objects damage, required less maintenance, and increased the load carrying capacity for the tires. This could only be accomplished by higher hardness and higher impact strength. The fuel tanks before the crash were made of a special aluminum alloy, AU2GN, that was lightweight and more heat tolerant than titanium. The fuel tanks were updated to be lined with Kevlar after the event. This cardboard thin lining used a rubber mat to be set in so that it could minimize the chances of a fuel leak or fire. Also, there were extra protective coatings put on the wire in order to minimize the chances of sparks. Let's talk about the structure and properties of these fuel tank materials. The aluminum alloy has a FCC structure. This allows for high ductility but low strength. The cause of the crash was due to the surface hardness of the fuel tank not being high enough to prevent the penetration and leakage. Kevlar, on the other hand, is a polymer. More than that, it has a crystalline organization which allows for high toughness, tensile strength, and chemical stability. Lining the fuel tanks with this polymer provides more protection to the possible punctures by providing a higher hardness.